All right, so now that we kind of have an idea of what these log graphs look like, we can get into some of the transformations here. So the next thing we're going to do is we're going to go to page 169 in your books then, and I'm looking specifically at this part. So what we've got here are 6 different functions and 6 different graphs. So what I want you to do is pause the video here and see if you can match up which function goes with which graph. So go ahead and pause, try that, and come back and see how you did. All right, let's see how you did. So the first thing I notice when I'm trying to graph these here is those first 3 functions are all exponential. And when something is exponential, I know that it has a horizontal asymptote. So I know this one, and this one have to go with those first 3 functions. So now I want to look at where are those asymptotes at. So in graph A, my asymptote is at -1, which would mean my function would have to go down 1. So I'm looking at the exponential function, so function A, B, and C is the only one that looks like it's going down 1, so that has to be A. All right, so I'm going to cross that one off since we used it. Now when I look at graph C, my asymptote is at 1, so up 1, which I'm thinking has to be this one. So that has to be graph C. Now when I look at graph F, so this is the last exponential function, and it's down 3, which matches this. So that has to be graph F. Okay, I'm going to kind of do the same process when I look at all the log functions here. So the rest are log functions, and I'm going to first look at that vertical asymptote. So B and D look like they have vertical asymptotes right at 0. But E, graph E, has a vertical asymptote at -2. So that function must have been moved left 2. So when I'm looking at the different equations here, I bet this one is the one that moves me left 2. So that one is graph E. And now I want to look at what's different about the 2 graphs that I'm left with. So looking at the 2 equations, the only difference is an x here and a -x there. So I know there must be some sort of reflection. So graph B is the one with a reflection, so that's got to be equation F. So this must be graph D. Okay, so that's what we're going to look at here. So going on to page 171 then, we want to look at these core concepts. So these are things you've seen. We've dealt with transformations a whole lot so far this year. So these are just specifically what the transformations look like for, this is then an exponential function. So horizontal translations, things like moving left and right. So we're used to that being with our x, which it is here. So in the exponent, if something is minus, I'm going to go to the right. If something is plus like this one, I'm going to the left. Moving up or down, so that's this one here. So that is kind of separate from the exponent. It's not with the exponent at all. If I have plus something, I'm moving up. Minus something, I'm moving down. So we're used to seeing that. A reflection then, so we could have a reflection over the y-axis or the x-axis. The x-axis is the one we're a little bit more familiar for. So the x-axis happens when that negative is kind of out in front of my base. Reflecting over the y-axis, the negative is in the exponent. Horizontal shrinks or stretches, so we'll do kind of just a little tiny bit with these. We'll see more vertical shrinks and stretches. So in this section, so that is when that variable is being multiplied by something. Right, the vertical stretch or shrink, so here, the one we're more used to, I'm seeing that value out in front of my base. So nothing's happening to the exponent there. So horizontal, my exponent is being multiplied by something. Vertical, it's out in front of my base. All right, so that's for exponential. We want to look at the same thing for the log graph. So very similar idea here, except for I don't have an exponent. I now have my variable inside the log. So same idea. If it's right with the x, and it's minus, it's going to go right. Plus, it's going to the left. We're used to seeing that. Now the difference here in this second one, so moving up or down, I don't have parentheses around that x plus 3. So it's log of x. The plus 3 is not inside the log. So that would tell me to move up. Minus would tell me to move down. A reflection, again, we can be over the y or the x-axis. So y-axis is inside the parentheses with the x. X-axis is out in front. Horizontal stretch or shrink, again, is right with the x, so inside the log. Vertical, then, out in front of the log. So we'll deal with more vertical stretches than we will horizontal, but still good to know where that's coming from. All right, so next we're going to do some practice here with some graphing. So we're going to go down to page 173. And we're going to start with number 1 there. Okay, so we're going to do some graphing with transformations. So if this is my function, 6 to the x, and this is g, 6 to the x plus 6. So I first want to say, what is that transformation? Well, that would be up 6. So this is pretty straightforward. I'm going to create my table for 6 to the x. So we've done this before. So let's see, this would be 1 over 6 squared, so 1 over 36, 1 over 6, 1, 6, 36. All right, and now I'm going to go ahead and plot those points. Now I know everything still needs to move up 6. So each of those points, 1, 2, 3, 4, 5, 6. I can't really draw in many more. So one other thing we have to think about when we're graphing exponentials is not only do I have to move all the points, I have to move the asymptote. So if the asymptote was at 0, I'm here at 0, I'm going to move that up. So my asymptote is now going to be here. Now draw in my function. Okay, so my asymptote also has to move. All right, let's look at the next one then. So f of x equals e to the x, and then I have my transformation there. So I know that this transformation is going to move my graph right 4. So I'm going to start with e to the x. Remember, for e to the x, we're going to do that table in our graphing calculators, or just a calculator. So I'm just looking at e to the x and filling in those x values. So we'll say 0.14, 0.37, 1, 2.72, 7.39. So I'm just reading those right off of my calculator. So if I plug in those values of x, what does that give me? All right, so we can go ahead and graph those. As I'm doing this, I'm just keeping in mind that I'm still going to need to go to the right, so I want to leave plenty of room there. So now when I graph here, negative 2.14, okay, so I don't want to connect those points yet because I still have to move right 4. So all of those points are now going to be moved right 4. Okay, so now I got to think about my asymptote as well. So if my asymptote started here at 0, if I take a line that goes forever in both directions and move it left or right, that's not going to change where it's at all. So when thinking about exponentials, only transformations that go up and down are going to affect that asymptote. Okay, let's keep plugging along here. So next, I'm getting into some of my graphs of logs. So my parent function is log base 5 of x, so I know I actually need to start with a table for 5 to the x. Okay, so that would give me 1 over 25, 1 over 5, 1, 5, 25. So then when I'm thinking about my table, I need a third column for that stretch in here. So I know I have a vertical stretch by 1/2, and this is going to move me left 7 in the end. Okay, so I'm going to flip-flop my points here. So 1 over 25, negative 2, 1 over 5, negative 1, 5, 1. Missed a point. There we go. Okay, so now to get from my second to my third column, I'm going to multiply by everything by that 1/2 that's out in front. So negative 2 times 1/2 is negative 1, negative 1/2, 0, 1/2, and 1. So now the points I want to plot are in the third and first column. I'm going to go ahead and I'm going to count by 2's here on everything. Okay, so 1 over 25, negative 1 would be out here. 1/5, negative 1/2. There. 1, 0. 5. Okay, so we kind of have that basic shape. And now I need to go left 7, so all of these points get moved left 7. Alright, so I also need to think about my vertical asymptote then. So if my vertical asymptote is starting at 0, I know that needs to go left 7. So right here, my smartboard is having a very hard time plotting where I'm putting my points, but I think you guys get the idea, and hopefully yours looks a little better than mine. So we have this graph here then. Alright, let's look at our next one we're going to do here is, let's jump down to number 6 then for our last one that we'll do together here. So now they don't give me a base for my log, so I know that has to be base 10. So I want a graph for, or a table for 10 to the x. So then my table for my log is going to be log of x for my second column. And then my third column will do that vertical stretch there. So we'll worry about the right 2 at the very end then. So I'm flipping my points. And now to go from the second to the third column, I have to multiply everything by a negative 3. Now I want to plot the first and the second column. So I'm going to count by 2's here on the x-axis. Count by 2's everywhere. down very steeply here.